Hi. So far for the concepts of DC machines, we have discussed the construction of DC machine first, which is similar for both DC motor as well as DC generator. Then we have also discussed the principle of principle of operation of DC motor as well as DC generator. Now we will see various types of DC motors and DC generators. We will be discussing only the types of DC motors. Anyways, they are common with respect to DC generators as well. Okay, so there are different types. How based on what factor they are divided? Mainly they are divided depending upon the connection of field winding. So if the field winding is connected with the armature, it is called as self-excited DC motor, and if it is connected separately, it is called separately excited DC motor. Why the term excited is coming here? Because the machine is excited through the field, so the supply of field is nothing but excitation. So by considering that excitation part, the types are divided. So if it is separately excited machine or motor, it is a separately excited DC motor where the field winding is not connected with the armature supply. That means the armature voltage supply will be different, field winding voltage supply will be different. So if you can see here, the field winding is connected separately with the armature. So armature winding is generally kept in the armature slots of the rotor, and the load is mechanical load is there because it is a DC motor which is connected through shaft. Fine. So this is what separately excited DC motor. So what is the advantage of this? With this, if you want to control any speed parameter or anything, you can control that either by field current or armature current, and they are independent of each other because their power supplies are different. That is a very good observation here. You can easily understand it. Fine. Right. So that is what I'm saying. So here if you see the torque equation, Tg is equal to Ka pi Ia, right? There we have the torque proportionality with respect to the product of pi, flux, as well as the current Ia, that is armature current. So the flux is produced by the field winding current, and armature current is there which is flowing through the armature. So right. So that means here if we can clearly say or indicate, this is the field winding current IF, and this is the current flowing through the armature IA. Right. So they are different because their supplies are different. You can independently control them, and in that way you can also control TG either using by flux or by using armature current. Right. That's how you can understand it. Fine. This is all about separately excited DC motor. So as I said, we can also connect field winding along with the armature winding. So there are different types of connections possible, right? Then you can get like series connection is possible. For field winding with respect to armature winding, we can have shunt connection, which is nothing but parallel connection. So parallel connection is nothing but shunt connection. So sometimes we can have both some part of the field winding in series and some part of the field winding in parallel. So then that will be like compound. Both series and parallel combination type will be called as compound. So all these are termed as self-excited machines. Okay, that means the excitation, that is field winding, is connected along with the armature winding. That's why it is self-excited. So based upon the connection, like if field winding is connected in parallel, it is called shunt wound DC motor. If it is connected in series, it is called series wound DC motor. And if some part is connected in series and some part in parallel, it will be called as compound wound DC motor. Fine. Right. These are the different types of motors. So we can see the connection. So there, here in this case of separately excited machine, field winding is separated from armature, which can be seen here. And in case of self-excited motors, field winding is connected in parallel with the armature winding. Fine. That you can see here. Okay. So for both the windings, the supply is common. DC supply is common. That's why it is self-excited, and that too it is shunt because field winding is connected in parallel, which is nothing but shunt connection. So in case of series wound, if you can see, See here you can see that field winding is in series with armature. Here the current IF will be equal to the IA, right? This will be IA and this is IF, means both are same, so we cannot independently control them. They are dependent. They are exactly equal to each other, right? Fine. In the next class, we will see few characteristics of DC shunt machine. Thank you.